Hello everyone, my name is Wizo NTR. Today I'm going to show you how to calculate a shear force in a simply supported beam. So let's start. Our RR is 46,261 kilonewton, and then our RL is 57,74. Let's see how to calculate the shear force. The shear force, let's start here. For shear force at A equals to, let's go and check. Shear force at A is 20 kilonewton. If you can check, we have 20 kilonewton. Let me highlight it by another color. Let's use yellow. This is 20 kilonewton. It's 20 kilonewton, and then it's negative 20 kilonewton. Why? Just because it's going downwards. Okay, let's go again to shear force at B equals to this negative 20 kilonewton minus another force minus 10 kilonewton. This is the shear force between A and B. This A and B, A to B. 20 minus, let me go and check, 20 minus 10 kilonewton. 20 minus 10 kilonewton equals to, let me do it in this way, minus 30 kilonewton. Let's go to shear force at B. Shear force at B equals to, let's go and check shear force at B. Shear force at B, it will be we said shear force between B and C, it will be the answer minus this one, 10 kilonewton. Then now we are saying shear force at C. Shear force at C, it will be the answer minus this one. It will be minus this one. So 57.74. 57.74. It will be minus 30 kilonewton plus 57.74 kilonewton. Let me go and check again. Yeah, so let me take my calculator and say 57,74 minus 30. It's how much? The answer is positive 27.74. 27.74. That's the answer. 27 minus, okay, kilonewton. So shear force at C, let me go and check. Shear force at C, at D, okay, C, D, between C and D, this is shear force at B. Okay, let me go and check. Okay, there is something which is wrong here. The first one, it was shear force at A. Then the second one, it is A and C. A to C. This one, it will be at C, not at B. C. This one, it will be at C. Now solve for this. Then let's go to shear force between C and D. Let me check. Yeah, between C and D. Between C and D. Shear force between C and D equals to the answer, which is 27.74 kilo Newton, minus force, which is between C and D, we have 6 kilonewton. It will be 6 kilo Newton. So let's go and get the answer. We'll say 26. This one minus 6 is 21.74. This is 21.74 kilo Newton. Let's go to shear force at D. Let me go and check on the drawing. Shear force at D, between C and D. Shear force at D, between C and D, we have shear force at E. Shear force at E. Shear force at E equals to 21.74 kilo Newton, minus the force, which is 11 kilo Newton. 11 kilo Newton equals to there's one minus 11 equals to 10.75 kilo Newton. Then we have shear force at, let me check, between E and B. Between E and B equals to 10 kilo Newton 0.75 minus, we had 11, 42 kilonewton. 42 kilo Newton equals to, okay, minus 42 equals to 31. 31.42. 31.42 minus 31.42 kilo Newton. Then shear force at the last point, it will be shear force at point, which is 15 minus RR. Then shear force at B equals to the last one. It will be like this. It will be minus 31.42 minus 31.42 minus 31.42 plus, just because that one is positive, or plus 1, 46. We can do it like this: 46.1 46.261 261 261 minus 15 equals to 0. That's all about the shear forces. So that's all about the shear forces. If you want to calculate the shear force, you must do it like this. Let me explain something. All forces which are going down, they are negative shear force. And let me say shear force calculations. This is shear force calculations from the previous or from the beam we calculated before. Then from here, I'm going to show you how to calculate the bending moment. How to calculate the bending moment. Then we will calculate the bending moment. The next video, it will be about the bending moments. Thank you for watching. Until we meet next time, calculating the bending moment.